Suppose that it is noon and you're trying to decide what to eat for lunch. You have $10 in your pocket and you have 1 hour. Where should you go? You can't travel too far since you only have 1 hour. You also can't afford a fancy meal. After considering some options, you decide to get a cheeseburger at a nearby fast food joint. This way, you have plenty of time to eat and also spend less than $10. Congratulations! You just used logical reasoning to solve a problem. We are constantly faced with small problems like this in life. How to dress, how to get to work or school, and so on. Frequently, when we're thinking about a solution to a problem, we're applying logic without realizing it. Logical reasoning often leads to a new conclusion or answer that we didn't know before. For example, in the lunch problem, you may not have known how you could eat for less than $10 in an hour until you thought about it. Next, let's consider a very different problem. Take a look at this triangle ABC. Now suppose that the length of segment AC is the same as the length of segment BC. In other words, the triangle ABC is an isosceles triangle. Then is angle A the same as angle B? You ask your friend Jake to answer this question. After thinking about this, Jake says yes, they are the same. You don't believe him, so you say prove it. Jake begins by adding a point M in the middle of segment AB. He then draws a line from M to C. Since M is in the middle of A and B, we know that segment AM is equal to segment BM. And we know that segment CM is equal to itself. Let's list everything we know so far. Length of segment AC is equal to the length of segment BC. And length of segment AM is equal to the length of segment BM. Finally, the length of segment CM is equal to the length of segment CM. Jake concludes that the triangle ACM is a mirror image of the triangle BCM. Thus, the corresponding angles must be equal, which means that angle A is equal to angle B. Jake described the logical reasoning process that led to his conclusion. This description is called a proof. Writing a proof is simply the act of writing down your thought process. As with the lunch problem, by logically reasoning about the triangle, we learn something new about isosceles triangles. Notice that we use 3 ways to describe the problem-solving process. Jake thought about a solution. Jake applied logical reasoning to arrive at a solution. Jake proved that his solution is correct. Perhaps surprisingly, thought, logical reasoning, and proved are closely related terms that we will sometimes use interchangeably. Let's use the isosceles triangle property to prove another statement. Take a look at this triangle. Suppose that the triangle XYZ is an equilateral triangle. That is, the length of the sides XY, YZ, and XZ are all equal. Let's prove that the angles X, Y, and Z are also equal. Applying the solution to the previous problem, since length of segment XY is equal to the length of segment XZ, we know that angle Y is equal to angle Z. Also, since the length of segment XZ is equal to the length of segment YZ, angles X and Y are also equal. Finally, if angle X is equal to angle Y and angle Y is equal to angle Z, then we know that angle X is equal to angle Z. We use the proof about angles in an isosceles triangle to prove a property about equilateral triangles. This is an example of combining a result of a proof with things we already know to prove even more things. Every time we prove something, we grow our knowledge basket. How much can we learn just by stacking proofs on top of other proofs? Euclid showed that we can teach a geometry course this way. It seems natural that most math subjects can be taught with proofs. But what about other subjects?